class, this is Mr. Roberts, Shasta High School. I want to step through another tool that you might consider using for some of your homework assignments. I know that we spend a lot of time looking at the TI 83 and 84 in class and how you use that tool to perform a lot of things, but many of you will go home in the evening and you don't have that tool available to you. Well, this tool that I'm showing you is a completely free download, geogebra.org, and it'll run on, if it doesn't matter if you're running Linux, Windows, 7, 8, Vista, XP, a Mac, or if you're running a tablet, right? If you've got an Android tablet, a Windows tablet, or an iPad, it'll run on any of those devices. The tablet version isn't quite as powerful as the desktop version, so I do highly recommend the desktop version. But if you only have access to like an iPad, you might try this. Although I think you'll be a little bit frustrated with some of the things it does and doesn't do. Anyways, I'm going to look at problem 72 from chapter 7, and I'm loving this CPM textbook. In chapter 7, question 72 says, each team in Mr. Zalowski's class cut a circular disk from a cardboard file folder. They could cut the disk any size they chose. The weight and radius were then recorded. The information is shown in the table below. Since students chose the radius, we'd like for you to consider the radius to be the independent variable. So what I've done here is I've recorded the data that's in that problem. Someone cut a disk with a radius of 9.6, and that one had a weight of 5.4 grams. This person cut a smaller one with a radius of 1.3, and it had a weight of 0.1 gram, a tenth of a gram. It says make a scatter plot for the data and sketch it on your paper. Describe the association between weight and radius. So here's what I want to show you how to do, is how to do that in GeoGebra. I think many of you know how to do that comfortably with the TIs, but you don't have it at home. Oh, we don't need this keyboard. So what I'm going to do is, if you don't have the spreadsheet view open, if you hit view, you can toggle off a spreadsheet, no spreadsheet. So there's my spreadsheet view. And in there, I went ahead and typed my independent variables in the first column, which was the radius, because they chose the radius and then cut that out. And then here's the dependent variable, the weight of it. When I drag a box around that, what I'm going to do now is right-click, and I'm going to go down to Create, and that might be slightly off the screen. Let me try that again. Drag it, and then I'm going to right-click, and I'm going to click Create. Unfortunately, you can't see this off screen here, but the Create has two options. It says List or List of Points. We're going to pick the second one down, List of Points. And when I do that, it immediately takes all those points and it treats them as X and Y's. And you can see I've plotted all of them. Love it. That was very quick, very efficient. And if you look at these, well, to me it looks like, well, as the, remember, this was my X-Y's is the radius of the circular disk. As the radius increases, I think it would be a fair statement that the weight of the disk increases as well. And we can see that relationship model or visually here. I'm going to go ahead and do a regression for this now. I want to go ahead and create a model that attempts to describe the relationship between the two. There are a couple commands that we're going to look at, and if you ever want to see an extensive list of all the commands available in GeoGebra, wherever your input bar is, at the very end of it, there's a small button here that will toggle help for this. And I hit it and it didn't really open it up, so I'm going to drag it over, I guess. Oops. There they are. This is the input help. So I can, now that that's over, I can just kind of open that and close that. So you can see all those there. We're going to use, I think, some of some things in the stats menu. And there is, of course, all commands you can see as one big alphabetical listing of everything that's possible with GeoGebra. So what I'm going to do is I'm going to use the FitLine command. So I'm down in my input bar. I'm going to go ahead and say FitLine. a line, and you can see it doesn't matter if you get the capitalization wrong, it'll suggest things here. So the FitLine command needs a list of points. So I click that. Now I have my points here listed individually and I can see all of them. But the list of points is stored in list number 1. So what I'm going to do is, whoops, right down below here, I'm going to type list, L-I-S-T 1, and then press enter. As soon as I do that, a couple things happen in Geogebra. It added this line of best square. This is the least squares regression line. And it also generated the model for me. So if I look over here, I can see y equals 0.65x minus 1.4. So here's a particular model that we have. One of the problems I see with this model, just off the bat here, is if I cut a circular disk with radius 0, that would be essentially this point down here. And I'm pretty sure that if I had a radius of 0, I should have a weight of 0. This says I have a magical disk that has a weight of negative 1.4. Unfortunately, in our Carnegie curriculum last semester, we didn't deal with something called residuals, and that's kind of been something that CPM has been mentioning often. So I want to just kind of briefly talk about residuals and give you an indication of when you might want to consider a residual plot. Essentially what a residual is every single one of these data points has a residual, and it's the distance between the y value for the recorded data point. So you can see this point A, it has a x value of 9.6 and a recorded y value of 5.4. Well, my model isn't saying that, right? This model has a different opinion. In fact, if I place a point, on this, and I ask it to, I'll show the label. Whoops, I don't need to show the label. Let me make it so that I can look at it and see its, let me put this back up here. I want to make it so that I can see its values. So I'm just going to say value, and then OK. You can see with this point right here, this is what the model is saying, right? So as I move around on the curve, the least square regression curve, for example, when I stop at around 9.6, which is, weird that is, you can see there's 9.6 and there's the point directly above it. When I stop at 9.6, you can see I'm getting a y value from my model of 4.8. Well, a residual is the difference between this predicted value, right? The model is predicting I would get 4.8, and the value that was observed or recorded when I cut out the disk and weighted in this case. So you can see that there's a residual here, there's a residual here, there's a residual here. In fact, almost all of these have some kind of residual. None of them are exactly on the line. Well, the interesting thing is that there appears to be a pattern for these residuals, and you can kind of see that. And a residual plot is basically when we go through and we collect up all those residuals and we graph the x value versus the amount of residual for each of the data points. Now I can generate that pretty easily in Geogebra, and I'd like to show you how to do that. Oops. So to plot the residual, it's another command we're going to use. I remember the first command we used was FitLine, and from that we got well, first of all, we generated a list of points from our spreadsheet, and then we used, then we plotted those points, and then we went ahead and used FitLine to create this least squares regression line right here. To look at the residual plot, the command is residual plot, R-E-S-I-D-U-A-L, and you can see it starts to pop right here, and you can just click that. Residual plot. This function requires two arguments. You can see there's two things here separated by a comma. The first thing it needs is the list of points that it's going to be plotting. So my list was list 1. I'm just going to click that. Does it let me do that? No, I can't just click it. Darn it. So I'm going to have to type that. So right here where it says list of points, I'm going to type list 1. The other piece of information it needs is the function that is describing the model. So let's make sure we understand, right? in order to create a residual plot, we need to figure out the differences between the observed value, that's for my data set, that's from list 1, and what the model says. So the model here is this line A. So I'm just going to type the letter A, that's the line, and I press enter. Now it shows this residual plot down below here, and I want to move to where we can see it. Not extremely helpful that all my other points are there. In fact, I want to see if I can turn these off real quickly. I'm going to go ahead and turn off all of my points thus far. So these A through G's, I'm just going to say don't show those objects. So what we're doing now is we're only looking at the residual plot. Well, when I look at the residual plot, I see, you know, it's not the case that these points are kind of distributed some, you know, randomly above or below this line equals 0. There looks like there is a pattern within this data. And when you see that, it's probably a pretty good indication that what you're looking at is not a linear regression model is not a good fit for your data. You want to consider other models for the data. Geogebra will do a nice job of creating some other models for this data. We did a linear regression line. In fact, that's this line A. I can go ahead and hide that line if I want for a while. And I think I can turn off, yeah, there's all my data points too, so I can show those and I can hide those. That's cool. I think I can color those too. Let me see if I was to bring this and say, oh, let's make these points a little bit bigger. And I'm going to make them, I don't know, I'll make them green. And then I'll say, okay. And that's cool. So there's my residual plot, and I can see that there's some kind of pattern going on there with those. In fact, before I show you how to create other models, let me bring this little graphic over here I just clipped from the web. So when you're looking at a residual plot, when you see, for example, you know, a random pattern like this where your residuals are scattered pretty much, there's no detectable pattern. It's in terms of their scattering between the predicted value and what the model says. Probably you might want to try a linear regression line, and then you can look at, you know, your correlation coefficient or your variance and see what's going on there. But when you see something like this, which is what we're seeing, this kind of non-random U-shaped curve or non-random inverted U-shaped curve, you probably want to move beyond a linear model. So let's go ahead and turn off these the residual plot, and I think I need to turn back on these points. So let me turn back on A through, there we go. I want to show those objects. So there's my data again. And now I'm going to create a different model for this data. We looked at a linear model. Now I'm going to look at a quadratic model. In fact, the command to do that in Geogebra is FitPoly. I'm going to fit a polynomial to this curve. It needs 2 arguments again. It still needs the list of points, and it also needs the degree of the polynomial that you want. I'm going to fit a 2nd degree polynomial to it. So my list of points still lives in list number 1, and I hit tab, and the degree of my polynomial will be 2. Now, as soon as I do that, I can see I've got this curve that just looks like it's doing a much better job of describing what's going on here as I look at the relationship between the radius of the circular disks and their weight. This is amazing. And in fact, I can go ahead and look at the I can look at the residuals for this plot as well, which is kind of an interesting thing to look at. Remember, the residuals was so residuals plot, and it needs 2 things. It needs the list of points. My points are still stored in list 1. The function I'm going to use this time is not A. I want to use the function f of x, right? This is the polynomial curve that we generated. And as soon as I do that, totally different night and day here. You can see that the residuals are just hanging along this line, y equals 0. So I don't see, I don't see any detectable pattern here at all, right? Some are above, over here some are below, some are above again, and some are right on. So, in my opinion, this is a much better model, and it makes sense to me too. As I know the radius, it's the radius squared that affects the surface area of these discs cut out of cardboard. And since they're all uniform thickness, it makes sense to me that a function that would have something squared in it would produce a better curve that fits this data. Anyways, that's it. That's 15 minutes or so of me trying to show you how to fit data to a curve. A couple of the big things we did was FitLine, FitPoly, and then Residual, RE. And as soon as you type a couple of the, RESI, as soon as you type a couple of those, they'll pop up on the screen and you can see, residual plot. I know that's off your screen, you can't see that, but it's there. So this is Mr. Roberts signing off. Have fun with your mathematics. I know I do. Talk to you later.